Yes. Now instead of only with the pencil, what we shall do is we shall try the activity piece of sandpaper around the cell. So how long does it move? Let us observe. So when you wrap the instead of now, okay. So here what shall we do is, now we shall try the activity by wrapping a piece of sandpaper around the cell. So before that, what we have done, we have taken the pencil and we have rolled over the inclined plane. Now what we are going to do, wrap the pencil with the sandpaper, and then you have to roll around the inclined plane. So what will happen to this? So how long does it is going to move? So is it going to take the more distance or less distance when it is not wrapped with the sandpaper? So let us observe. Yes. So friction, it is caused by the irregularities on the two surfaces which are there in contact. So how friction it is caused? It is caused by the irregularities. Irregularities, how smooth the surface may be, but you are going to find some irregularities. So then the friction will be developed. Even those surfaces will appear very smooth. They have a large number of minute irregularities on them. So we have said that now. So though there is a smooth surface, here the table it appears as a smooth surface for us. But here what will happen? If you observe, there will be a small minute irregularities, and friction is developed when there is irregularities between two surfaces. Irregularities on the two surfaces lock into one another. In the irregularity, then only the friction will be locking with one another. That is, the two surfaces will be interlocking with one another. If you are taking the surface of the book and the surface of the table, so here it appears, the book and the table, they are going to appear as for us smooth surfaces. So what we say that a friction is developed. But how it develops is by locking the irregularities. When we attempt to move any surfaces, we have to apply force to overcome this interlocking. Now you are trying to move. You are trying to move an object. So how to overcome that? That is how you can move the object to overcome the interlocking. To overcome that interlocking, when you are going to apply the force. So this will be getting independent. Then only the object will be moving. On rough surfaces, there are large number of irregularities. So force of friction will be greater, and if the rough surface is involved. So if the force of friction will be greater if the rough surface is involved, and the force of friction will be lesser if smooth surface is involved. That means the pencil takes long distance, the smooth surface it is having. That means the force of friction will be less there. When you take for the rough surfaces, the irregularities will be more. So the force of friction will be greater. So we see that the friction is caused by the interlocking of irregularities in the two surfaces. It is obvious that the force of friction will increase if the two surfaces are pressed harder. So force of friction, it will be to overcome the friction. Okay, how much you are applying, that is to overcome the friction. So if two surfaces, if they are pressing harder to each other, that means if the surface of the, so if you consider a box, if you move along the surface, so if both of them, if you are going to press hard, then more force of friction you have to apply. So force of friction, it will be increasing when the two surfaces are pressed harder, and you can experience it by dragging a mat when nobody is sitting on it and when a person is sitting on it. So take a mat and try to drag it. So what will happen? You can drag very easily. That means you have applied some less force. That is, the force of friction will be less. Why? Because the irregularities there are so smooth. So it has applied less force. When you take a person which is sitting on the mat, then if you try to drag it, so you apply more to overcome the friction. So you can recall your experiences when last time of chalk particles which stick to a moved heavy blocks from one place to another place. So you can recall your experience when last time of some chalk particles which are sticking to the board, and also when you push a heavy box from one place to the another place. If you don't have any experience, then you can get the experience now. So what it will be easier, like to move a box from rest or to move it when it is already in the motion. Okay, now consider a box which is moving, or consider a box which is at rest. Now where you need to apply more force, either on the box which is in motion or on the box which is at rest, you need to apply here more force the box which is at rest. Why? Because the surface has interlocked there, and to overcome that you have to apply more force. Okay, and when you are observing here, the block which is in motion already, that is going to move easily. So the force which is required to overcome friction at that instant an object starts from rest, it is a measure of the static friction. So it's a type of friction. So what is meant by friction, we understood. So friction is that which opposes the resistance, or which offers the resistance to the motion of the body which is in moving, that is motion of the body which is in moving but in the opposite direction. So friction is the resistance which is offered to the object in the motion in the opposite direction. Now here what you are going to observe is the force which is required to overcome at the rest, you are going to move the object. So whenever it is interlocking the surfaces, how much force you have applied to move the object. So that friction we call it as static friction. So static always stays or means that it is at rest. So from rest, if you are going to start an object, so how much force you have applied. So if at all, if there is a force of friction which is going to oppose that, so how much force of friction is there? So that is called as a static friction. On the other hand, the force required to keep the object moving with same speed is a measure of sliding friction. So what is a sliding friction? We have friction like static friction. So that is the object when it is going to about to start from rest. The friction how much is there? That is the static friction. And already which is in motion, the object which is in motion, so it is continuing to be in a motion, then how much of speed the object it is moving, it is a measure of the sliding friction. So we got two types of frictions here. One is the static friction, another one is the sliding friction. So you can observe here, so this is the force which is applied on an object, so it is going to slide. So when it is starting to slide, so that friction it is called as static friction, and when it is sliding over that, that is called as sliding friction. When a box starts sliding, the contact points on its surface does not get enough time to lock into the contact points on the floor. So how the sliding friction is existing, let us observe. So when you are going to box, if it is sliding on the object, so it does not get some time to interlock with the surface. So it requires some less force. So sliding friction is slightly smaller than the starting friction. Starting friction, already the objects are interlocked. When they are interlocked, we need to apply more force and we need to overcome the friction. And when it is sliding, it requires some slide force. So always we say that sliding friction, it is slightly smaller than the static friction, and you find it somewhat easier to move the box already in the motion than to get it started. So you can say that, so which is object which is already in motion, it is easier to move that, whereas the other object to start from rest, it takes more force. So next let us see friction, a necessary evil. Okay, so let us recall some experiences. Is it easy to hold a kulhad, that is earthen pot, or a glass tumbler, which is easier? Suppose the outer surface of the tumbler is greasy or has a thin layer of cooking oil on it. Would it become easier or more difficult for us to hold it? Just think, would it be possible to hold the glass at all if there is no friction? Yes. So is friction a necessary evil, he is asking now. So like this, so you can hold a kulhad, that is the earthen pot, or you can hold a glass tumbler. Which is easier for us to hold it? I think the earthen pot is easier than to hold a glass tumbler. Now what you do is make the tumbler greasy. When you make the tumbler greasy, can we hold it? No. Okay. Or if you apply a small cooking oil to that, can you hold it? No. Okay. So would it be possible to hold the glass at all if there is no friction? Can I hold this pen if there is no friction? No. If there is a friction in between my fingers and the pen, then only I can hold the object. So is friction necessary? Yes, it is necessary. Yes, you can recall how difficult it is to move on a wet muddy track or wet marble floor. So when you are asked to move on a wet muddy track, can you move so fastly how you are moving on the surface? No. Or on a wet marble floor? No. So why is that? Can you imagine being able to walk at all if there were no friction? Can we walk on the surface if there is no friction? No, we cannot walk. You could not write with pen or pencil if there is no friction. When your teacher is writing with chalk on the blackboard, its rough surface rubs off some chalk particles which stick to the board. So if there is no friction, you cannot hold a pen or you cannot walk on the floor. Could it happen if there were no friction between the chalk and the board? So I cannot write on the board. Why I cannot write on the board? If there is no friction, I cannot write on the board. If an object started moving, it would never stop if there were no friction. So we have taken that a ball which is moving on the floor. I have applied some force and it is moving. So when it is moving, if there is no friction which is going to act in the opposite direction, could that object will be continuing if there is no friction. So here, if there is no friction, that object will never stop. So had there been no friction between the tires of automobiles and the roads, if there had been no friction between automobiles and the roads, then those will not move. They could not be started or stopped or turned to change the direction of motion. If there is no friction, some things would not happen. Like you cannot hold the pen, like the automobiles cannot move on the road, or you cannot walk on the floor. You could not fix a nail on the wall or tie a knot. So all these actions are not performed without the friction. So what can we say now? Is friction necessary? Yes, it is necessary. Without friction, no building could be constructed. On the other hand, friction is an evil too. So it is also necessary for us and it is also evil for us. So how it is necessary for us? We are able to walk, we are able to write, the automobiles are able to move on the road. So if one object is standing over the another object, then we say that friction is necessary. If there is friction, then only that can withhold. Otherwise, we cannot make those some things to happen. If you are moving a ball, so that is going to never stop if there is no friction. So friction, it is necessary. So on the other hand, it is an evil also. In what way it is evil? Let us observe. It wears out the materials where there are no screws, ball bearings and soles of the shoes. You must have seen worn out foot over bridges at railway stations. So when you are going to observe, so if there is a friction, so if there is a more friction there, so you can observe the worn out of the shoes. So that is the friction, it is going to remove the first layer of the shoes. When you are walking, due to the friction, the first layer gets moved off. So there are screws where you can see the first layer of it will be worn out. And also the ball bearings or the soles of the shoes. So where friction is necessary, friction can also produce the heat. Vigorously, when you rub your palms together for a few minutes, how do you feel? So when you are going to rub your palms like this, so when you, after some time, if you check that, so it is going to be, you are going to observe that your hands will be somewhat warmer. So why they will be warmer? So as you are moving one object over the other object, so that is, when you move one object over the other object, there is a friction which is developed there. So due to that friction, it is going to develop the heat. When you strike a matchstick against the rough surface, it catches fire. So that is also due to friction. You might have observed that a jar of a mixer becomes hot when it is run for a few minutes. So you can observe when your mother, if she is putting the mixer jar, so when it is run for certain time, so what will happen? That is going to produce some heat. So why does it produce heat? Because a friction which is present there in between the jar and the mixer. So that is going to produce the heat by continuously rotating it. You can cite various other examples in which friction produces heat. In fact, when machine is operated, heat generates, causes much wastage of energy. We shall discuss the ways of minimizing friction in the following section. So there are some ways to minimize the friction, and that is necessary for us to minimize the friction. As friction, it is going to be wastage a lot of energy. So it is going to waste a lot of energy when high machines are operated. When high machines they are operated one over the other, they will be moving. When they are moving, the first layer will be worn out. So to decrease that worn out, so what we have to do, how we have to minimize the friction, let us discuss. So how to increase and decrease the friction? As you have seen in previous section, friction is desirable. So it is important to have the friction in some situations. Have you ever thought why your shoe is grooved? So you can observe here the tires of the vehicles, they are threaded, and you can also observe the sole of your shoes, they are grooved. So why it is done? To give a better grip. Yes, to give a better grip on the floor so that you can move safely. So why to give a better grip there? So why is it grooved? So as you are having the flat sole, if you are having the flat sole, what will happen is the friction will be more, the sliding will be more. So to reduce that, you are using the grooves. And you can also observe this, the threads which are given to the tire, those are also to reduce the friction between the road and the tire so that the objects moves safely. so that you can move safely. Similarly, the threaded tires of cars, trucks and bulldozers provide better grip with the ground. So you can observe here, to minimize the friction, the soles of the shoes and also the tires threaded, because to move them friction or to reduce the friction there and to move safely. And you can also deliberately increase the friction by using brake pads in the brake systems of bicycles and automobiles. So you can increase the friction in some ways. So how you can use the increase the friction? By applying the brake pads in the brake systems of the bicycles and automobiles. And when you are riding on a bicycle, the brake pads do not touch the wheels. But when you press the brake lever, these pads, they arrest the motion of the rim because of the friction, so that you can stop easily. The wheels stop moving. You might have seen that kabaddi players rub their hands with soil for the better grip of their opponents. So you might have observed that the kabaddi players, what they will be doing is, before entering into the field, before starting the wrestling, what they do is they will be rubbing their hands with the soil, so that they will get the better grip with the opponent person. And also you might have observed that gymnasts, what they do, they will be applying some coir substance on their hands. So they will be applying coir substance on their hands, that is some rough material they will be keeping on their hands, gymnasts. Before starting the weightlifting, what they do, they will be applying some white color powder. If you are or Olympics, or if you have seen some Commonwealth Games, what they do is, before going to enter into that, what they do, they will be applying some powder. So why they will apply their powder? So to make that, to reduce the friction. So when you are catching that weightlifters, the rod will be smooth, whereas your hands also will be smooth. So it may get us, so that will be getting slipped off. To not to get slipped off, they will be applying some powder. So that is to reduce the friction. So gymnasts apply some coir substance on their hands to increase the friction for better grip. In some situations, however, friction is undesirable. So some situations it is undesirable and we would want to minimize it. Why do you sprinkle fine powder on the carom board? So you can observe that children while playing, there will be some carom, they'll be spraying some powder onto that. So why they spray the powder? So you might have noticed that when a few drops of oil are poured on the hinges of a door, the door moves smoothly. So the door gets stuck. What you do? You'll put some oil so that it moves smoothly. A bicycle and a motor mechanic uses grease between the moving parts of these machines. So it is for the increase of the friction. In all the above cases, we want to reduce the friction in order to increase its efficiency. So whatever we have observed, you are going to reduce the friction and you are going to increase the efficiency of the objects. Like when you are taking machines, when they are moving, so there will be loss of energy. To increase that, you have to efficiency, you have to reduce the friction. Oil or grease or graphite is applied when the moving part of a machine and a thin layer is formed there and the moving surfaces do not directly rub against each other. So you will be saying when machines are moving, to move easily, what they do, they will put a oil or they will put grease or graphite. So it is applied between a moving part of a machine. So that develops a thin layer which it is going to the surfaces that does not rub against each other, so that they move safely and easily. So if they move one over the other, if the surface touches one over the other, what will happen? There will be owning out of the first layer. So interlocking, by doing this, what will happen is the interlocking of irregularities is avoided. Why you will be applying oil or grease? Because interlocking of irregularities is avoided to a greater extent. Movement becomes smooth, then the substances which reduce friction are called as lubricants. So you will be adding oil, grease or some graphite, so which they reduce the friction. So these are called as lubricants. In some machines, it may be advisable to use oil as the lubricant. An air cushion between the moving parts used to reduce the friction. An air cushion also, it reduces the friction between the moving parts. Can we reduce friction to zero by polishing surfaces or using large amount of lubricants? No, we cannot make or we cannot get the friction to zero.